Alright, in this video we're going to talk about Unit 2, Objectives 8 and 9, derivatives of inverse functions and inverse trig. So when we're finding the derivative of an inverse function, the thing that we're going to need to remember about inverses and their functions and their inverses is if we have the point AB on a function, then we know we have the point BA on its inverse. So using that, we're going to say that g of b is going to be the same thing as f inverse of b. Now notice that this is not x, this is b, as in b over here. It's the y value on the function, the x value on the inverse. So we're using this to find the derivative of a inverse function at a given point. So the derivative g prime of b is going to be equal to 1 over f prime of g of b, which we're also going to think about as 1 over f prime of f inverse of b. And again, we want to keep this thing in mind, this relationship where AB is on f of x and BA is on g of x, so that we're going to take that into account. We're going to have to remember that f of A equals b means that f inverse of b equals a. This relationship here is going to be very, very critical for finding the derivative of an inverse function. So there's two ways that you're most likely going to see this on the AP exam. One is with a table, like we have here, and then the other is with a function, which we'll see in the next example. So select values of a strictly monotonic function. We'll talk about what that means later. G and its derivative g prime are shown in the table below. Find g inverse prime of 1. So thinking about the rule that we just came up with, this is going to be the equivalent of g inverse of 1 equals something, right? We don't know what g inverse of 1 is, but we have this relationship that we're going to know that g of that same something is going to equal 1, right? So the x value on the inverse equals the y value on the function. So if we kind of keep this pairing in mind, we can look at our table and we just have to find when does the y value equal 1. So if we're looking at g of x, the y value equals 1 when the x value is 1/2. So I know that this question mark is equal to -1. So that tells me g of -1 equals 1, but that also tells me g inverse of 1 equals -1. And why that's going to be important is our rule for the inverse function. So the inverse of g prime at 1 is going to be equal to 1 over g prime of g inverse of 1. Well, we just figured out that g inverse of 1 is -1. So this is going to be equal to 1 over g prime of -1. Go up to our table, g prime of -1 is -1/5. So it's 1 over -1/5. So we get an answer of -5. So the trick is we always need to come up with this relationship here so we can come up with our derivative. So let's take a look at an example where we don't have a table, but we have a function to deal with. So if f of x equals the quantity 2x plus 1 squared and g of x equals f inverse of x, find g prime of 9. So again, we want to start by thinking g inverse of 9 equals something, right? We don't know. But we do know that f of that same something is going to be equal to 9. So that means if I plug that question mark in here, so 2 times something, so 2 question mark, plus 1 squared equals 9. So 2 times question mark plus 1 equals 3. 2 times question mark equals 2. So we know the question mark is going to equal 1. So we know that I'm sorry, this should say f inverse, not g inverse. F inverse of 9. We know that f of 1 equals 9, And we now know that f inverse of 9 equals 1. So we can now think about this. So g prime of 9 is really f inverse prime of 9, which is going to be 1 over f prime of f inverse of 9. We know from up here that f inverse of 9 is 1. So we're looking at 1 over f prime of 1. So that's g prime of 9. So we just need to find f prime of 1. Well, if f of x is the quantity 2x plus 1 squared, we know f prime of x, that's a prime, is going to be 2 times 2x plus 1 to the first power times 2 because of our chain rule. So f prime of 1 is going to be 2 times 1 is 2 plus 1 is 3 times 2. So f prime of 1 is equal to 12. So g prime of 9 is 1 over 12. So the two things that we have to know is f inverse prime is 1 over f prime of f inverse of b, and we need to be able to make this connection here. If we can do that, these problems shouldn't be too bad. So the other thing we need to talk about is inverse trig rules. So just like regular trig rules, inverse trig rules are going to rely on the chain rule. So just like before, this u is a function of x. It could be x squared, x to the third plus 4, whatever, just a function of x. The derivative of arc sine, so a little note, arc sine is going to mean the same thing as inverse sine of u. Generally, AP is going to use the arc notation, so that's why I put it here this way in our notes. But the derivative of arc sine of u is going to be u prime over the square root of 1 minus u squared. And if you think about what happens with normal trig, if I have sine, the relationship between sine and cosine is just negative. So arc cosine is going to be negative u prime over the square root of 1 minus u squared. Derivative of arc tangent is going to be u prime over 1 plus u squared. So there's no square root in this one, u prime over 1 plus u squared. And again, if we have arc cotangent, we're just going to have negative u prime over 1 plus u squared. Alright, so to practice this, let's find y prime of x if y equals arc sine of 5x to the 4th power. So just like thinking about trig, we want to think about that inside u being 5x to the 4th. So our u prime is going to be 20x to the 3rd. And now we have our u prime, so it's just knowing our rules. So y prime of x is going to be equal to u prime, so 20x to the 3rd, over the square root of 1 minus u squared, so 5x to the 4th squared. When you go to simplify this, because it's going to be multiple choice, this isn't going to show up on a free response, make sure that you square both the 5 and the x to the 4th, so we're looking at 1 minus 25x to the 8th power. So this one's just know your rules, and the other ones, remember, with the just inverse functions, we need to know the relationship between the point on the function, the point on the inverse, and then 1 over f prime of f inverse for the derivative. So that'll do it in this video. We'll see you in the next one.